I just want to talk through a little bit about the altar stone. And I've only got literally half a dozen slides about this, so I'm not gonna go on for too long. But I thought I might talk about this because it's quite interesting in that this is something that really made the news last year, and you probably saw this on the news about the idea that the altar stone may well have come from northeast Scotland, which, if it's true, is an absolutely amazing finding and really does throw things up in the air about Stonehenge. Now, bit of context, and I don't like, it's difficult this, I don't like necessarily talking about other people's work. I'm much more comfortable talking about my own. I don't like critiquing other people's work. I'm happy critiquing my own. So these are my views, yeah? So I'm just going to caveat it by sort of saying that. But the altar stone's has been the subject of interest for quite a long while. So it's a sandstone. It's there are other sandstones at Stonehenge, but it's the one that's right in the middle of the monument. It's also one that's really quite difficult to analyse because it's sitting underneath two fallen sarsen stones. So the stone there, I think, is stone number 55, which has fallen over and broken in half. That's its lintel stone there. So it's kind of buried underneath. There it is. This is what it looks like. So you can just about make out a bit of it there and a bit under this stone here. This is from 1958, when, as well as doing the re-erection of the sarsens, they also did quite a lot of digging and excavated around the altar stone. So you can see it's kind of, I'm not sure about the size of it. It's about 3.5, 4 meters long, and it's a kind of oblong slab of a micaceous, slightly green sandstone. We don't know whether it was standing up in the past or whether it was laying down. There's no clear way of knowing that because they haven't found base holes for the stone. But as you can see from here, it's sitting right in the middle of the monument. It clearly was quite an important stone as part of the construction of Stonehenge. Now, it's worth saying, excuse the small print here, compared to our work, so we started almost with a clean slate on the sarsens. Nobody had really ever done any proper work on whereabouts the sarsens came from. So we were kind of starting from not very much. The altar stone has had a ton of work done on it, and it's been very incremental. So there's people like Rob Ixer, Richard Bevins in particular, that have done lots of smaller studies building up information about where the altar stone might come from. And I've kind of plotted it as a bit of a timeline here for you. But I guess the picture, at the end of the 20th century, it sounds like we're talking a long while ago then, doesn't it? It was only 25 years ago, but end of the 20th century, the prevailing idea was that probably the altar stone was picked up en route from the Preseli Hills to Stonehenge. And that idea has been around since the 1920s and the work of Thomas. Atkinson suggested it was probably from around Milford Haven area on the basis of I don't know what evidence, but that was the kind of idea. It must have been picked up en route with the other blue stones on the way to Stonehenge. And then there's been all sorts of studies. So people have looked at thin sections and said, well, it must come from the old red sandstone outcrop in South Wales in a particular layer of that called the Senni beds. And then there was other work that found excavations at Stonehenge had found sandstone fragments, and the suggestion was that, well, these fragments must be debitage, they've got to be debris knocked off the altar stone. And then people did analyses of those fragments and said, well, actually, it's probably got the closest match to the eastern end of this Senni beds outcrop. They were kind of honing in on South Wales as a possible source. Studies from the 2020 looked at the clay mineralogy of the altar stone and suggested it was probably from southeast rather than southwest Wales. Yeah, then we did more PXRF work like we'd done, but in this case, analysing the actual altar stone itself and looking at these fragments again and saying, well, these are probably the same materials. I'll critique that in a little moment. But linking them together. Then there was a paper that came out in 2023 saying, oh, it's got a very high barium content. It doesn't look like it's from the old red sandstone in Wales. We need to look a little bit wider afield. And then in 2024, lo and behold, I'm sure they already knew that they were looking further afield, me being cynical, but that was when the paper was published about the stones coming from the Orcadian Basin in northeast Scotland. So we've kind of gone, and there's other steps in between, but that's the kind of the journey. We've gone from South Wales now through to northeast Scotland as the likely source. The paper from 2024 is this one. You can look at it online. It's open access, fully available, called A Scottish Provenance for the Altar Stone of Stonehenge. It's quite a techie paper. So it's kind of a not for the light-hearted paper. But what I've tried to do on this next slide is summarize it in 4 bullet points. So I'll try and explain what they did, because it's different to how we did this. And I'll also enlarge those graphics in a moment as well. But basically what they did for this study, so we were looking at chemistry. In this case, they were looking at the ages of minerals within the stone. So they were looking in particular at 3 minerals, zircon, rutile and apatite, which are very resistant minerals, which you find in a load of sandstones. And they determined the ages of those individual zircons. Now, the ages of zircons, as an example, relate to, so they form within igneous rocks. Imagine you've got like a granite, like in Dartmoor. When that granite was still molten underground, it was still magma. It would all have been, all the chemistry and different elements would have been mixed together. Things start to crystallize out. Zircons, rutiles and apatites crystallize out. And if you can figure out the age of the zircons, it gives you the age when the granite formed. So the little minerals record the age of magmatism, if you want to think of it in that way. And the idea then is that if those rocks are then eroded and the little zircons get washed out into sediments and those sediments become sedimentary rocks, you can then, if you look at the ages of your zircons within your sedimentary rock, there's potential to see how those age profiles compare with original rock sources. And in some cases, you might get more complex histories in an area. So you might find, for example, that there's an original, I don't know, an original granite, and then a long while after it's formed, there may have been another magmatic event. It might be caused by mountain building or something. That then generates zircons of younger age. And then that whole landscape's being eroded. So your rocks might include a diagnostic mix of different ages of zircons, for example. And that's what they did. They basically looked at thin sections of the altar stone. They looked at thin sections of sandstones, and they compared the mix of zircon, rutile and apatite ages. That sort of makes sense, broadly, I hope. I'll show some graphics that will hopefully make it clearer. But what they picked up from the zircons was that there were 2 main groups of ages of zircon present. One of them dated back to a period between 1 and 3.5 billion years ago. That's probably during that boring billion, I guess it is, pretty much, that you might hear about tomorrow night if you listen to that talk. These rocks were thought to be part of what's called the Laurentian area. They basically, this is an old landmass that was made up of crystalline igneous rocks. And a lot of those rocks were formed around about 1 to 3.5 billion years ago. And then also there was a signature from about 460 million years ago, which reflects a period of mountain building that was associated with the building of the Grampians in Scotland. So what you've got are these sandstones within the altars, the zircons within the altar stone, having this kind of bimodal, not quite, but bimodal signature of ages that suggest it's a mix of Laurentian and Grampian rocks that were eroded in order to form it. So what they then did was they then did these age comparisons. They got this profile, I'll show you it in a second, and then they compared it with sedimentary rocks across the UK and did something very similar to what we did. We used direct numerical matching. They do statistical matching, but they kind of see which age profiles match most closely with the altar stone and different areas around the country. The 2 main graphs they show are on the right, and I'll just enlarge these. So the left-hand one is a statistical technique called multidimensional scaling. Don't need to worry too much about the detail, but what it does is it looks at the data set of all these ages that are generated from the stones, and then it kind of pulls apart age clusters from different areas. And what this shows, basically, there's the altar stone, and it shows it has quite a strong overlap. It's very close to Laurentian signal, but it overlaps most strongly with the Orcadian Basin signal of ages. And you can see that also on the right-hand side. It's a bit more fiddly diagram, but this is showing what's called a cumulative probability curve. And it's a bit like you're looking to see which lines most closely match. And if you look at this, the altar stone, which is this kind of reddy orange, most closely matches the black line running through here. So on the basis of statistical similarity, that this is really where they've got the suggestion that the altar stone most likely comes from the Orcadian Basin. It's basically by comparing the age profiles of zircons and rutiles and apatite within the rock with age profiles of other rocks in different parts of the British and Irish Isles. And it shows a bit more nicely on this graphic, actually, because that's the profile. So this is a bit more of a bit like a bar chart or a histogram, but smooth, so there are sort of peaks on it. This is the altar stone at the top. That's the record from the Orcadian Basin, and you see there's this kind of double peak, which is this Laurentian zircon profile, and there's this bump down here, which is the Grampian profile, and matches up with that. You can see also it doesn't match several other basins, and they include loads of diagrams of these profiles from the other basins. Now, that's basically the story of how they did the matching. And hopefully that kind of makes loose sense. So it's statistical similarity between a zircon, rutile, apatite ages for the altar stone versus different areas. Now, if you read the paper, quickly, you'd be thinking, wow. And I did when I read this, I was like, wow, that's incredible. Then I read it in a bit more detail. I still thought, wow, that's incredible. But I started, I guess, probing a little bit more deeply into some of the things that what they've done. Some of them, and I'm going to present this. I'm not going to necessarily, make judgment about it. But there are some things in here where I wonder about the strength of the evidence that they've got. And I'm just going to pick out 3 issues. So number one, bit like our work, sampling issues very much come into this. They analysed 2 samples of what they argue were pieces of the altar stone. So these were pieces that were found in the National Museum of Wales from excavations and Salisbury Museum. They also the only new analysis of old red sandstone in this paper are 2 samples from Orkney and 1 from Caithness, both of which were bought from a shop in Whitby, which I found really intriguing. But there we are. So there's not actually any field work involved in this at all. Not a problem with that. I don't have any problem with that. But where you'll see in a moment, where it does cause some problems is you don't exactly know where it sits in the stratigraphy, where exactly your samples are from. Then they compare it against data from the Orcadian Basin from a paper by Strachan et al. That's what produced the black wiggly line on that previous graphic. That's only from 5 samples of rock. So what you've got is a kind of quite a big story about Stonehenge based on analysis of 2 bits of altar stone and largely 7 samples of old red sandstone, 2 of which were bought from a shop. I won't emphasise that. But what this means, from my critique of this, if I was looking at this, no fieldwork undertaken, no problem with that, because a lot of studies use secondary data. But it does mean you don't have information about the stratigraphic context of your samples. More worrying for me is that these 7 samples are meant to be characterising the old red sandstone sequence in a big basin. And the old red sandstone sequence in Caithness is 4 kilometres thick. In Shetland, it might be nearly 8 kilometres thick. And you're trying to characterise that from 7 bits of rock. That's for the benefit of the Zoom viewers. I just went, okay. So that's my take on that. I think it's quite a big ask, and it's quite a big jump there for me to say I've characterised a basin on a fairly small number of samples. I'm moving on. The second thing are the zircon spectra themselves. So I've zoomed in now. I showed this part of the diagram before. There's the altar stone that's based on 2 samples. Here's the Orcadian Basin that's based on 7. I delved into, because I was really interested in this, I went into the Strachan paper to try to see how variable those profiles were that are used to create this graphic. That's the same bit at the top there. So this is kind of a smoothed out version of that profile at the top there. But if you look at these 5 zircon profiles from their 5 different samples, which are scattered all over northeast Scotland, none of them match that. So this paper is basically, claiming a match between the altar stone and zircon profiles that don't actually exist, if I'm being really harsh about it. Now, I'm not a zircon specialist, so I don't know whether this is conventional that in an area you combine your data sets to make one, but that struck me as being a bit odd personally, because what it means is there isn't actually a rock outcrop anywhere out there that they've sampled that actually matches the altar stone. At least we could say, well, we've got pieces of rock that chemically are, you know, indistinguishable from that rock over there. At least we could say that. Here, you don't have anything that directly matches. So again, that for me is a question. And then the final thing, which again, I started reading, because I was really interested in this. And it's one of those things, the more you read, I then sort of started to wonder, well, actually, are the samples they analysed from the altar stone actually from the altar stone? And if you look back, I mentioned there was the paper where in 2023, they used PXRF, so the same kind of ray gun that we used. They analysed some of these excavated fragments of altar stone. And then they also went into the field and did PXRF readings on the altar stone itself. And then they compare them to see, well, do these chippings come from the altar stone? And they claim that they do. They plot there's lots of different plots here. I've just picked a few out here. But I have to say, some elements work really, really well. There's really good agreement. I've listed a few here. That plot's beautiful. Yeah, so the red ones are the altar stone readings. The open bluey greeny symbols are the chippings that they analysed. That works really well. There's a really clear relationship, and you know, all of the different readings all fall on a straight line. That one's not bad either. There's a big spread, but they all kind of overlap. That one, goodness me, the reading up there for barium is absolutely distinct, barium and strontium, a completely distinct cluster to all of the other readings. Over here, this is the reading from this stone down at the bottom. That one's got much lower levels of iron than all the others. It's that same stone again. There's some real variability. And if I was looking at this, I wouldn't sit there and say these are the same stone, personally. I would look at it and say there's something odd going in here. I'd be trying to explain why there's high levels of strontium and low levels of barium. I'm not sure I would actually say that they are definitely from the same stone. So there's good agreement for some elements, bad agreement for others. Now, the worrying thing is that I've underlined the two stones. Those are the two samples that they use in the Clark et al. Paper, including this green one, which is really a bit iffy. And I haven't started, when I got to that point and I started thinking, well, I don't know whether these samples are even from the altar stone, and you've taken 7 analyses to characterize an entire 4-kilometre thick section, I'll leave it at that, I think. But I read this and I became really, I suppose, very, very critical of it. And if any of the authors are watching the Zoom video, I apologise. It's my personal view. It would be fantastic to have a chat, really, to find. I'd like to know a lot more about why you stack together your zircon profiles to make a profile for an area. I'd love to know why that's done. I'd love to know why you say that these stones are exactly the same thing. But there we are.